One way of spotting high-quality lead crystal glass is to give it a ping, and if it's good, it should produce a lovely clear note. Now compare that to ordinary glass, and you can really hear the difference. However, it's the way that the lead crystal glass resonates that makes it more vulnerable to death by opera singer.
Lead glass resonates or vibrates more than normal glass because it's softer. The theory is, if you can exactly match its natural resonance, and with enough volume, the energy from the sound wave created by the human voice can cause the structure of the glass to literally vibrate to pieces. We've recruited singer Claire Noakes to test the theory.
And now we're going to put theory into practice, and Claire is going to attempt to shatter this glass using her voice alone. It's a combination of exactly the right frequency and a great deal of volume. So you ready, Claire?
Yep.
Unfortunately, we seem to have got you the heaviest lead crystal glass in the world.
Well, I'll see what I can do.
OK, do your best. This is your note. Do you want to have another go?
I'll have another go.
OK, I'll give you your note again. It was definitely singing back that time.
Yeah.
OK, third time lucky, and this time I'm going to try and give you some help. I'm going to join in, OK?
Yep.
Right, let's go.
So, what went wrong? Well, despite what you've been led to believe, it is impossible for a singer to break a modern glass. It simply can't be done. Modern wine glasses are just too well made. For this experiment to succeed, the glass really needs to be damaged or flawed in some way, and then it is possible to bust one apart. One of the biggest breakthroughs in glass making in modern times was the development of a perfectly flat kind of sheet glass called float glass. This revolutionized the glass industry by allowing, for the first time, the mass production of high-quality, perfectly flat sheet glass on a truly epic scale.
This UK plant alone produces 10,500 tonnes per week. It's enormous.
The line runs 24 hours a day, 7 days a week, and it is never switched off. It will run for at least 10 years before being ripped apart and rebuilt. And amazingly, this whole operation is overseen by just a few people. The process begins at the hot end, where raw ingredients are shoved into the furnace, which burns at temperatures of over 1500 degrees Celsius. Once the glass has been formed, it's then stirred before being moved on to the next part of the operation.
OK, I don't know if you can see this, but this is where the float process starts. The liquid glass is tipped onto a bath of molten tin, and at this point the temperature is still in excess of 1000 degrees centigrade.
This is what makes float glass so perfectly flat. The liquid glass literally floats on a river of molten tin. And what you're seeing here is a perfect reflection of the heaters in the ceiling, because at this point in the operation, the tin-backed glass behaves like one giant mirror. Once floated, the glass is lifted off the tin. At this stage, it's still relatively weak, and it needs to be carefully cooled before it's ready to be cut and handled.
Having emerged from the inferno, this is the final product.
It's an endless ribbon of perfect flat glass, and it's off to be cut to size and packed.
And even here, the machines still rule. Diamond-tipped computer-controlled cutters slice the glass into sheets, and then robot suckers lift the sheets off the line and place them into neat stacks. But this isn't the end of the story. These uniform sheets will eventually be sent out to secondary glass producers who will cut and mould the glass into everything from double glazing to car windscreens. Still to come, we find out how the professionals test glass, and we bring out the big guns to do our own extreme glass testing.
If you ever fancy swapping your stairs for an escalator, then one like this will set you back £50,000. But once installed, it will carry 150 people per minute. That's 9,000 every hour and 216,000 in a day. It's the best people-moving device we have, and its design has changed little since its invention in the 19th century. In the late Victorian era, American inventor Jesse Reno was the first to see its potential.
In 1896, he displayed a moving walkway at Coney Island, and though it was just an inclined slope without any steps, 75,000 people came to ride on it. A few years later, the idea was further developed and the modern escalator was born.
Here's how it works, and it's really quite simple. An electric motor powers a large drive wheel at the top of the escalator, which pulls the steps round. When they get to the bottom, a smaller wheel returns the steps so they're continuously going in a loop. All the steps have rollers which ride along a tracking system, and the clever bit is that at the top and the bottom, this track levels out, pulling the steps flat and making the escalator easy to get on and off.
The name escalator comes by merging the words elevator and scala, which is Latin for steps. An escalator is known in some circles as a comic book featuring tales of alien pornography. How bizarre!
The more common escalators aren't involved in alien porn, but they have to be regularly serviced, which includes a good bit of hoovering, oiling and disassembling for routine inspection.
Pull it out and then it twists out through that gap.
There you go. Very rarely steps have failed and people have fallen into the machinery, which is pretty gruesome and gives rise to escalator phobia. One of the biggest fears is that your scarf or shoelaces will get caught and you'll get sucked into the machine. This combed arrangement is designed to make it impossible for something to be dragged inside the mechanism. It's a physical barrier which deflects items over it. But if this safety device fails and something gets dragged inside, the escalator is designed to automatically stop. It was precisely this sort of fear that gave an Edwardian chap called Bumper Harris his job. When the first escalators were installed on the London Underground, Bumper was paid 4p a day to ride them. He only had one leg, so the theory was that if people saw him using them, they'd feel safe to have a go as well.
The world's record for going up and down escalators is 7 days non-stop, which equals 140 miles. The same man who completed this feat also has a world record for ironing. The longest single-span escalator is in the Washington Metro, and it's 155 metres long, which is nearly double the wingspan of the world's largest aeroplane. The smallest is in Japan and is 83.4 centimetres high, which is smaller than your average 10-year-old.
The optimum slant for an escalator is 30 degrees, but the best thing about them is that if they stop working, they simply convert to stairs, which is why it will take something special to get rid of the millions of escalators that link our world.
Soap has been around since 2800 BC, and billions of us use it every day to get ourselves clean.
So what is it that makes soap